All right, gang, we are going to talk about our 4.1b notes, triangle sum properties. We're going to get into the practice problems on page 2. I want to remind you about what our goal is for this lesson. And our goal is to know how to name a triangle, only given points, and after graphing it. So I'm going to give you some information, some points. We're going to graph it. We're going to find out about the lengths of the sides and how we can classify it. So what I want you to do now is to pause the video, and then we will jump ahead to page 2 and get into the practice problems. All right, we're going to be using these practice problems. We will be graphing triangles and then figuring out what kinds they are. The directions that we have right here are to graph the points given and classify the triangle according to the sides and angles if possible. So I have already taken these points right here. I took the first point, -4, 5, and I put it on my graph. I went back 4 and up 5, so I'm going to label that point right there F. And then I graphed U, which was back 4 and down 1. So I'm going to label that point U. And then I graphed the point N, 5, -1. So from the middle, always measuring from the middle, we go to the right 5 and down 1. And that point we're going to label N. And now we're going to draw those lines. So get out your straight edge if you like. Otherwise, I'm just going to connect those guys with my lines. And we will measure the sides. A couple things that I want you to think about is if you want to find the length of a horizontal or vertical segment, all you need to do is count the squares in your graph. Remember, horizontal is something that goes side to side, and vertical is something that goes up and down. And then if we want to find the length of a non-horizontal or non-vertical segment, we need to use the, and that would be distance formula. And then think about that. What was that we had to do our distance formula? And I got a little blank for you. Remember, we had that big square root. And then inside that square root, we had to put some quantities. Remember, it was x minus x, quantity squared. And then we put in that plus. And then we had a y minus y, quantity squared. So we're going to be doing that. So now what I want you to do is go back to your triangle. And let's measure the bottom of the triangle from the U point to the N point. And all we have to do is count the squares here. 1, 2, 3, 4, 5, 6, 7, 8. That measures 9 squares. And then we're going to measure from the U point to the F point. 1, 2, 3, 4, 5, 6. So right now we have 2 different sizes in our triangle. And then the last point, or the last side, the FN side, we have to measure that. And notice that that is one of those non-horizontal or non-vertical segments. We will use our distance formula. So again, remember the distance formula was x minus x squared, and then y minus y squared, and we're doing it from F to N. So we're going to be using these numbers and these numbers. And if we think about it, remember we used that little triangle? And we actually already know them. The y distance from the top all the way to the bottom was 6. And the x distance from side to side we have on the bottom here is 9. So since it's all graphed, we can use the numbers that we already came up with. We square those guys and we add those guys, and we will take the square root of that. 9 squared is 81. 6 squared is 36. We will add those together, and that turns out to be 117. And when I plug that into my calculator, I get 10.81. So if I look at the three numbers that we have on this triangle, 10.81, 9, and 6, I can see that all three of those numbers are different. That makes this a scalene triangle. Now, if we want to think about the angles of the triangle, the one angle that really sticks out to me is this angle down in the corner, the U angle. And you notice that it actually follows the boxes right there. That actually is a 90-degree angle. So because we graphed it, we can see that that's 90 degrees, and so we can call this a right scalene triangle. All right, we're going to pause this guy right here, and I'm going to jump down to question B. So we're looking at question B, and we notice that we have these 3 points. We have the A point, we have the B point, and we have the C point. I want you to take and graph those 3 points, and then I'll come back in a second, and let's compare what we have. All right, check your graph. Make sure that it looks the same as mine. A is up on top, one space from the top. It's up 6 spaces. Then we have B at -4, -2. And then we have C at +4, +2. Remember, you were measuring everything from 0, 0. So we were going left and right. X's, we went left, right. The Y's, we went up, down. Then from there, we're going to draw our triangle. So when I draw that, I have these 3 sides. And if you look at that, the easiest side to find is the bottom side, the BC side, because we notice that it goes straight across. We can count these spaces, 1, 2, 3, 4, 5, 6, 7, 8. BC is equal to 8. Then we have to find the other 2 sides. And when we want to find the other 2 sides, remember that we're going to use our distance formula. So we can use our points and we can subtract them. This B point, remember, is -4, -2. And the A point is 0, 6. And the C point is +4, -2. Or remember, we can draw our triangles on here and we can just calculate. My X distance, 1, 2, 3, 4, is 4 spaces. So if I'm going to do, let's see, AB, my X distance is 4, and my Y distance goes up and down, 1, 2, 3, 4, 5, 6, 7, 8. And I square that, and then from there I square each of those, and I get 16 plus 64. 8 times 8 is 64. Take the square root of that, and I get the square root of 80. If I plug that into my calculator, I get 8.94. Then, when I want to do the other side, I notice that I draw my triangle, and if I count my spaces, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, I get the exact same numbers. It turns out that A to C is exactly the same as A to B. Because I have the same X distances and the same Y distances. That means these 2 sides are congruent and the bottom is different. Remember, the bottom was 8. And so that makes us have an isosceles triangle. Now, if we want to decide if this is acute or obtuse, the thing that we want to think about if we wanted to do it mathematically would be to determine if there's a right-hand angle, we need to actually use our slope values. So that's back last year, a review of last year. And then hopefully you learned that if the slope products equal -1, then your lines are perpendicular. And that means 90 degrees. And if your slope values are equal, then your lines are parallel. Now, parallel, not so important when we're doing triangles. We really are concerned of whether we have perpendicular lines or not. When you're calculating your slope, remember your slope is your rise over your run. So if I'm going to look at the numbers that we have in this picture, I'm going to count my rise 8 and my run 4. The slope of this line is 8 divided by 4, which is equal to 2. And for the second line, my rise is 8 and my run is actually -4. So this slope right here is 8 divided by -4, which is equal to -2. And since 2 times -2 does not equal -1, I know that those are not perpendicular lines. It appears that it is a right triangle, but we can't actually say that. So it looks right, acute, but we don't actually know that. We just know that it's not a right triangle. So for this problem, we are just going to answer isosceles, and that's good enough. What I want you to do is pause again, and I will jump down to question letter C, and we will connect again. For this question C, I want you to take a second and graph those points, and I will get those drawn on there, and then I will connect back with you here in just a second. All right, I have my 3 points on there, P, Q, and R, and I've drawn my triangle. And now we need to calculate the distance of actually all 3 of those lines, because none of them are horizontal or vertical. None of them run along the graph. So we need to use our distance formula 3 times. I want you to practice that. I'm going to get it worked out here, and then let's connect back in a few minutes and figure out if we have the right answers. All right, the first segment that I did was RQ, and RQ is this guy right here. That is 4, 4. So when I did my distance formula, it looked like this. RQ equals 4 squared plus 4 squared. Squared each of those numbers, got 16 and 16, added them together, got 32, and then hit square root on my calculator, 5.66. Then the next segment that I did was the PQ segment, and PQ is 8 across and 2 down. The X distance is 8 and the Y distance is 2. So I did my calculation for PQ, and I got 2 squared plus 8 squared. That gives me 4 plus 64, total of 68. Took the square root of that. I got 8.24. And then the last segment that I did was the PR segment. And those, the X distance going across, the X distance right here was 4. And my Y distance was 6. So when I put that onto my formula to do PR, I got 4 squared plus 6 squared. Gives me 16 and 36 when I square those numbers. Square root of 52 equals 7.2. Then I noticed that all 3 of those numbers are different. 5.66, 8.24, 7.2. That makes this triangle a scalene triangle. If I were to measure my slopes for each of these segments, I could measure the rise and the run. And so again, we measure from point to point. If I want to measure from R to Q, I would go up 4 and over 4. That makes this slope 4 over 4, which is 1. And then I can measure from R to P. And again, I measure up and then I measure over. So I go up 6 and over 4. That means that the slope for this guy right here is 6 over 4. If I reduce that, I get 3 over 2. And the last segment, if I wanted to do that, I would measure my rise and my run. And notice I'm going backwards on that run, so it's going to be negative. I go up 2, but I go backwards 8. That means that that slope on that one is up 2 and back 8. That gives me negative 1/4. And if I took any of those numbers and multiplied them together, none of them, negative 1/4, 1, or 3/2, none of those numbers would multiply to negative 1, so I do not have a right angle in this triangle. And other than right angle, that's all I can measure. So I think that it appears to be acute, but we don't answer anything because we don't really know. And so this is only a scalene triangle. If you have a couple problems like this in your worksheet, I want you to give them a try. And if you have questions, we can talk tomorrow in class. Good luck. See you later.